Okay, so we have just given you the little homework assignment of figuring out what the stack would look like with the following operations. So let's go through this together. So the very first item it's pushing onto the stack is the value 1. So 1 is at the top of the stack. Then it's going to push 2 onto the stack. And now we have a pop item. Pop means it's going to remove an item from the top of the stack. So we're left with the top of the stack at 1. And then it pushes a 3 on. So now we have a 1 and a 3 left in your stack. Okay, so one thing about we've talked about several data structures to allow you to store data. Now, these are going to be some algorithms to go back and retrieve your data once it's stored. So there's 3 types of algorithms we're going to talk about. We're going to do a linear search, a binary search, and a hash table. So a linear search works with unsorted data. You could do this with a linked list. You could do this with an array. You wouldn't have to do it with a binary tree because that's already sorted. But what it does is if the data is unsorted, there's no particular order we could go in. So suppose we're looking for the value 12. The easiest way is to just start at the beginning of the list and search through until you find the item you're looking for. And there's our 12, and so we found it at that point. So just works with any kind of data. It's just starting at the beginning and searching through till you find your item. That is a linear search. Now, a binary search is going to be a little bit more efficient. It works with sorted data only, though. That is the difference. You could still do this with an array, a little bit more difficult and less efficient if you were using a linked list to do this. But a binary tree, that's already going to be a binary search. Okay, so let's show you how this works. So you just find the midpoint and disregard half of the list. So for example, suppose we're searching for the value 57. Well, let's just search right here in the middle and start our search there instead of at the beginning. And since 57 is larger than 28, then this entire half of the list is not going to be in our search space because it was smaller, and we know that this information on the right is bigger. Okay, then it's going to do that again. It's going to cut our list right in the middle and then just disregard that entire list, and it's going to keep doing that until it finds its item. So that is a binary search. Here's an example. Guess a number between 1 and 100. If you were to try and guess this number, what is the most obvious thing that you would guess? If it's just a random number between 1 and 100, you would probably guess 50 right in the middle. And I would tell you, search lower because it's not. So then the next time you could guess somewhere between 0 and 50 or 1 and 50 because I said 1 and 100, didn't I? So you could guess right in the middle, I don't know what, but you'd keep eliminating until you finally found the values that you were looking for. That's an example of a binary search.